At this time, I'd like to introduce our speakers on stage with us this evening. Donna Jackson Nakazawa is the author of 3 previous books exploring the intersection of neuroscience, immunology, and emotion. Jackson Nakazawa has appeared on Today, NPR, NBC News, and ABC News, and her work has appeared in the Washington Post, Health Affairs, Parenting, Glamour, and has been featured on the cover of Parade as well as in Time and USA Today. She lives with her family in Maryland. Our interviewer this evening is Aneri Pattani. Aneri is an investigative health reporter for Spotlight PA, a collaborative newsroom working to hold state government accountable in Pennsylvania. She's also a current recipient of the Rosalind Carter Mental Health Journalism Fellowship, which is supporting her in pursuing a year-long project on college students and mental health. Previously, Aneri covered mental health, suicide, and health disparities for the Philadelphia Inquirer. The book we are here for this afternoon is titled The Angel and the Assassin, which is available for purchase up at the front counter. In the book, Nakazawa tells a thrilling story of scientific detective work and medical potential that illuminates the newly understood role of, how am I pronouncing this?
Microglia.
Microglia, my goodness. An elusive type of brain cell that is vitally relevant to our everyday lives. The book has received praise from numerous media outlets and authors, but I'll leave you here with my favorite blurb about the book. The Angel and the Assassin is one of those astonishing medical yarns that you almost can't believe. How the power of this tiny cell was so long overlooked, how integral it has become to our understanding of neuroscience and immunology, how it has transformed the most basic ideas of who we are as humans. The book is essential reading. At this time, please join me in giving a warm round of applause for Donna and Aneri.
All right, well, thank you all for coming out, and thank you, Donna, for being here for the chat.
Thank you.
So I have to say, in reading this book, I found it really fascinating. As someone who is often reporting on mental illness, I think every time I'm speaking with people who have experienced themselves, number one question I get is why? Why did this happen? Why are my doctors treating the symptoms and not the cause? Why do we know so little about this? And I think reading your book was one of the first times where I felt like there was a really deep dive in trying to answer that question. So for anyone who hasn't read it, I won't spoil it all, but as Alex was saying, the book is about microglia, which are a cell in the brain, and it's somewhat like a white blood cell in that when white blood cells become overactive, you can develop autoimmune disorders like lupus or arthritis or MS. Same way, if microglia become overactive, you can develop psychiatric disorders, and there's a connection between your physical immune system and the immune system in your brain.
Well done.
But just want to have a little bit of basis as we're talking about this. But one of the things that kind of struck me throughout the book is answering that question of why and really diving into this wasn't just a professional curiosity for you, it's also personal. So I wonder if you could tell us a little bit about how your personal experience shaped your reporting, the way you interacted with the patients who are in your book, and maybe if the reporting process has changed your outlook on your own health.
Sure, great question. So thank you for having us, by the way. Cool place. I started this journey looking at microglia without kind of realizing I was doing it. I was recovering from a second bout of Guillain-Barré syndrome, which is, you could just say it's a lot like MS. It's a disorder in which it leads to full paralysis. And that recovery was a good 2-year period. And as I was getting better, not great, but better, I noticed a lot of cognitive changes. So this is around 2008. I would be trying to tie my daughter's shoes, and I'd be thinking, wait, I'm going back to bunny loops here. Like, how do we do this? Kitchen table math with my kids at the kitchen table, 7 and 8, my brain would stutter a little bit. I remember at one point reading Harry Potter to my son, and that scene where the Dementors, those sky, drifting ghouls come and they just steal a person's happy state and their ability to think, and it's just gone, and they replace it with kind of this dead dread. And I thought, wow, I'm like the Dementors. Like, this is not my brain. These are not my legs. These are not my hands. This is not my brain. And I went to my team at Hopkins, who are state-of-the-art life-saving, saved my life. And at that time, it was categorically believed that the brain and the body function completely separately. Lots of reasons for that. We can thank early anatomists. We can thank early philosophers for that, and we can talk about that if you want to. And the thinking was that if you had an autoimmune disease and you were suffering any kind of cognitive or depression or anxiety, that it was related to the fact that it's stressful, right? It's hard. It's hard to be paralyzed. It's hard to have an autoimmune disease. But also right around that time, and I thank her in the book, I have some amazing friends who are scientists. And one of them at the University of Maryland, Peg McCarthy, a good friend, and I were talking, and she started telling me about this little cell and that it was going to cause textbooks to be rewritten, that it was changing everything we had ever thought we knew about the brain function, psychiatric disease, Alzheimer's, and the way in which our body's immune response is connected to our brain's response. Around the same time, epidemiologically, a large number of studies came out showing that individuals with different autoimmune diseases, from MS to rheumatoid arthritis to lupus to Crohn's disease, people with gum disease, individuals who'd had bacterial infections, we're all more likely to develop cognitive changes and mood disorders in the brain. So I just set out to look at the research. When I did, I saw no one was talking about it, and I really set out to tell a scientific detective story coming from my own frustration and maybe compassion for other people suffering as I was suffering.
And you started to hint at it a little bit, but this is a really important cell, right? You wrote a whole book on it.
Yes.
But how was it missed for so long?
Well, so I want to set the stage. It's really a story of contrast. So on the one hand, we have believed for over a century, and you could say 3 centuries since the time of Descartes, that brain and body functioned as church and state entities, and he came up with that mind-body dualism, which trickled down through academia for the next 3 centuries. But early anatomists had other reasons for thinking that the brain was immune privileged, and that was due to, anybody know what the blood-brain barrier is? So this dense constellation of red blood cells that sits at your brain stem was thought to make it impossible for your body's immune molecules to rise up into your brain. Early anatomists had another reason for thinking the brain could not function as an immune organ, and that is that, let's say you're hanging pictures and you hit your thumb, and it gets red, hot, painful, and swollen, which is our definition of inflammation. Well, the brain is an organ with this hard skull on top of it. So early anatomists assumed it must not have its own internal immune system because the immune system functions through red, hot, painful, and swollen. And then the other contrast that sets the stage to what we know now, contrasting what we thought then, just 10 years ago, and what we know now, is how microglia were seen and categorized and ignored when they were first discovered. So they were just noted and named in the 1920s by Spanish neuroscientists. They were thought to be like the other 3 glia cells, which I won't all name here, but a family of cells in the brain that aren't terribly important, or so they thought, that emerge in gestation from nerve cells. So when we're developing in the womb, all of our cells are stem cells, and those cells differentiate, some of them into our hair and skin, some of them into different organs, some of them into different cells in the body. Well, a body of stem cells develops into nerve cells, and glia cells were thought to be these little nerve cells in the brain, not immune, right? Not like the white blood cell, not like your T cells. Non-immune cells, and microglia were the tiniest of these little cells that were wrongly categorized as nerve cells, and they were thought to be entirely boring and irritating. So boring, they just took dead neurons and carted them away, or catered to the needs of neurons in the brain. And neurons, let's face it, are the flashy darlings of the research world, right? So microglia catered to them the way that an entourage caters to a movie star. You need a little sip, okay, you're tired, let's take you away, end of story. And microglia were also very irritating because they ruined researchers' experiments. They had this creepy way of getting into the petri dish when you didn't think they were there. And so they were misnamed, miscategorized, because they were called glia, and they're really immune cells, ignored, cursed, and thought to be boring. And in an organ that's non-immune. That's how we missed it.
Jeez, a lot of barriers there.
Yeah, right.
So one of the things in the book, most of the patients, or all of the main patients that you speak of, are women.
Yes.
And there's a special section on teenage girls and anxiety as well. Mm-hmm. And of course, you touch on the effects with microglia for men and boys too, but yes, definitely the idea that women are at the center of this book comes across. I'm wondering.
Oh, you noticed.
I'm wondering why that was important to you.
Really important to me. So having been a reporter for a really long time now, I have reported on a lot of women in science, a lot of women writers, a lot of women in medicine. And as women have been coming up in all of these different fields, it's been interesting in that at the same time, one of the things women have been fighting against is inclusion of women in all of these different medical studies, right? So friends of mine have written books about it. Maya Dusenberry, if you know Maya, wrote a whole book about this. So we're very conscious of this as female reporters, like women aren't in the studies that we're reporting on. And I'm also very conscious because I write at the intersection of neuroscience and immunology and human emotion that most of the immune-mediated disorders on this planet strike women at 2 to 9 times the rate of men. Now, there's a whole story to that. And in fact, the next book, I'm going to be talking more about that. But we now understand that women and girls are facing 2 to 3 times the rate of serious depression, major depressive disorder, generalized anxiety disorder, mood disorders, Alzheimer's. And in autoimmune disease, the number is 3 to 9 times. It has a lot to do with the female body and estrogen. But it just didn't seem right to me as a reporter for 30 years that most of the people doing the research were men, excluding women from studies, when most of the patients are women who are suffering, and many of these women have been accused of being malingerers for so long across the scientific history of science. That's why. And just to add a coda to that, the women at the forefront of this research on microglia, the top researchers in the world are all women. And I think, and I have a theory, that when women have to break things to make things and do it in their own way and ask questions that are outside of the accepted science, they become less afraid to take it in the direction that they might have a hunch in pursuing, and we can talk about that. But the female researchers who took this research all the way had to break rules and ask questions that no one else was asking in the history of neuroscience. And I find that kind of amazing. And this is not, I report on male scientists all the time, all my career, but I wanted to shine a light on the women who are leading this field and the patients who stand to benefit from the research. So thank you for noticing, and I hope no one is offended by that.
Can you give us, I know you said the next book is on this, but can you give us a little preview of why women are more affected by these things?
Yeah, so it has to do with the fact that, nature, I always think as a science writer that nature is smart, but not that that smart, like really smart. We're being protected from all kinds of onslaughts just as we sit here. Every millisecond, there's probably a little mold in the old books, and probably, people are coughing, and our immune system is 24/7, just keeping us so healthy. It's extraordinary. It's just amazing. But at the same time, our immune system can become very stupid over time. And with the onset of estrogen in puberty, the shifts in estrogen after childbirth, and the shifts in estrogen in menopause and postmenopause, estrogen works hand in hand with our stress response, how we respond to the world around us, and our immune system driving hard. Now, I want to ask you guys a question. Can anyone think why that is for women? We have to do something men don't have to do. We have to protect the fetus in our lifetime, across evolutionary time, many times. And that biological imperative to protect life is so great that estrogen pumps out this very big threat immune response when women feel threatened by chronic, unpredictable, toxic stress that drives these things called cytokines, which are these immune, think of them as inflammatory agents in the body. And as that inflammatory response rises, it protects another life. But over time, it does havoc to a woman's body and to the genes that oversee the action of our immune system and microglia.
So one of the women in the book, Katie Harrison, there's a point where she says she would rather people assume that she's a bad mom than to tell them she, couldn't get her son to school because of her anxiety and depression. And that really resonated with me. I think a lot of times when I'm interviewing people on this topic or asking people to be part of an article I'm working on, the issue of stigma around mental illness is huge. So how do you think, or maybe hope, that the research around the biological basis and microglia will affect stigma?
Well, I'm really hopeful that, that again, I look over the course of reporting. I wrote a book called The Autoimmune Epidemic a little while ago. And when that book came out, women felt, and men who had autoimmune diseases, felt really stigmatized by having these hard to diagnose, difficult to describe, difficult to test for diseases that we knew existed, but it was really tough to get doctors to take them seriously. It was really tough to get respect, even within the medical community, for having something that we know is happening, but we can't go inside and see what's unseen. And one of the reasons I set out to do that book was because I wanted to legitimize the patients who were suffering, so that even though some diseases appear to be invisible, they are still physical, and to be taken as seriously as a patient who walks in and says, I have cancer, right? Or heart disease. And so to me, understanding that microglia cells can become overactivated in the brain by an onslaught of many stressors, in the same way that we know that the human immune system can become overwhelmed and overtaxed by stressors and develop inflammation and autoimmunity and disease, to bring this home by following these researchers and telling their stories and following the patients, to me as an understanding that the physical will become emotional and the emotional will become physical. They are one thing. The body and the brain are in a 24/7 immune crosstalk. We can no longer go with Descartes. Descartes had it entirely wrong. Mind and body are not dualistic. They are functioning in tandem. The brain is responding with its own immune response 24/7 to every little micro message that it gets from the world around us. It is our seventh sense. And if we continue to treat it as this black box mystery where we don't know what the heck is happening and we just throw things at it and hope it gets better, then we will never, ever make any progress in terms of stigma and in terms of treatment. Patients who walk in for help with mental health disorders are getting the same treatments they got 30 years ago, all based on the idea that the brain is not an immune organ, is not affected by our immune system, and that everything comes down to chemicals. And guess what expresses the different chemicals in the brain? Microglia.
So what you said that, people walking in today with psychiatric illnesses, same treatments are being offered as 30 years ago versus you look at something like cancer and we've come so far. Yes. So I was actually reading an editorial you wrote for the Boston Globe about this book, and you said something similar.
Yeah.
And you mentioned, there are a lot of different reasons for the translation from research to practice, but one of them was around sort of what is the monetary incentive for treatments that address mental illnesses or address issues like microglia. Mm-hmm. Can you talk to us a little bit about what are some of the barriers that, there's a lot of great research and a lot of potential treatments in this book. Mm-hmm. What keeps it from making it accessible to everyone who needs it?
Right. So, well, first of all, good clinical data, we can't ever, we don't ever want to jump ahead of good clinical data. But what pays for good clinical data? Right? So how does good clinical data get done? Well, obviously, big pharma has all kinds of incentives to pay for good clinical data, and often legitimately, run studies over and over. We have so many studies showing that Zoloft and SSRIs have about a 33 to 36% efficacy rate, right? But big pharma can throw money at that all day long, and for people for whom medications work, fantastic. I will never, ever, ever be anti-medication. That's not me. I think all the tools in the toolbox matter and save lives. But let's look at something like transcranial magnetic stimulation. Well, those researchers, they have to go and they have to raise funding to do that research. Right? There's no big pharma incentive there. Let's look at things like neurofeedback, which is getting a new look because of microglia. It's been considered woo-woo for a really long time, but now that we understand the role of microglia in the brain, people are taking a new look. Well, those researchers have to go out and get their own funding. There's no payoff for anybody at the end of the day for most of the treatments that I cover in the book. There's a lot of work going on regarding fasting mimicking diets seem to be rebooting microglia. No one's gonna make a dime off of this, and that's good for patients because there are a lot of things that we have a lot of agency to do in terms of looking for recovery. But so I'm trying to think what I can say and what I can't say. I have reported on researchers who know that certain things happen in the brain after concussion or in psychiatric disease, and that certain applications of existing drugs could make an enormous difference. But they cannot get funded by big pharma. So that's why part of the reason in writing the book, I really wanted to help the patient see that there are all these tools in the toolbox in addition to medications that, I guess the best way to say it is we're our own driver. We're our own driver. A lot of things aren't going to be told to you in a clinic because there is not that same relationship between medicine and medications. I hope I'm answering that.
Yeah, and let's take it a little step further. I mean, you often say you write about science to make it accessible for people.
Yeah.
So I guess what is the hope if I am someone struggling with a mental illness or struggling with an autoimmune disorder, that I read this book and then I'm empowered to do what?
Right. So I think that you are empowered to do things on a micro level, no joke, sorry, and on a macro level. So on a micro level, there are certainly many different things that I talk about in the book that one can pursue. Some are ready for prime time, some are really just in development. I make that really clear in the book. There are some things coming, like MIT is working on gamma light flicker therapy, which seems to be re-instructing microglia to behave very differently. And actually in those experiments, which are now well into clinical trials, human clinical trials, microglia stop being bad guys. They stop eating synapses and spitting out neurotoxins, which hurt synapses and hurt neurons. And they morph back into good workers, and they clear tau protein in the brain in Alzheimer's models. So that is not ready for prime time, right? That's going to take some time. There are lots of things that are ready for prime time that are happening right now, and a patient has agency to ask their healthcare provider, their psychiatrist, and work closely with a provider so that they know what they're doing is safe and appropriate for them. But on a macro level, I think there's a lot of agency because, now that we have this understanding that our brain is responding 24/7 to the world around us in an immune way, we have to treat our brain the way we treat our immune system. We have to think about the different choices that we're making. We create the world we're living in from the stressors that we live with and how we respond to them. We can't always shift the stressors we live with. I know that better than anybody. But our shift in our response to the world around us, our shift in how we eat and exercise and the choices we make about what we put in our body and the therapeutic relationships that we have, the social connectedness that we have, our brain is responding to all of this. Are we safe? Are we not safe? Are we safe? Are we not safe? Microglia get overwhelmed and overtaxed when too much is too many onslaughts and hits are coming its way. So I think that just knowing that the brain is your immune system is your brain, gives us a lot of agency for a different way in to thinking about self-care and motivating us to take the best care that we can of ourselves.
And when we talk about the brain sort of having this onslaught of stressors, there's a chapter in here where you discuss how that may have to do with a decrease in the microbes that we're encountering, right? Our immune system used to be busy with all these things in nature that a lot has changed. And I think a very simplistic reading of that can be, do we need to live in a more dirty way? Which is obviously not the case. But when people read that, what does that mean? Is there anything actionable in terms of should we be trying to expose ourselves to something or not expose ourselves to something else?
So this is the too clean hypothesis, which is that, we used to live with lots of different worms and helminth worms. Anybody ever heard of helminth worms? Okay. Well, we used to live with all these different microbes, which we evolved with over time, which helped to educate our immune system. And a lot of those are gone, the kinds of things that swim around in our environment and tell our immune system to keep busy with these old familiar foes. So many different microbes and pathogens don't harm us, but our immune system knows them and has evolved with them over time and can get kind of busy with them. So we now are in a land of, minivans and vacuumed homes, and we don't have the same microbial exposures that we used to have. Instead, we have non-microbial environmentally toxic exposures. So you take an immune system that evolved over time with these different pathogens, learned how to be really smart across millennia with them. You remove those, you introduce all these things that your immune system does not recognize. We did not evolve with, the 100,000 chemicals that were, in being exposed to every day. We did not evolve with social media as like this, constant threat message. We did not evolve with the crap in our foods. We didn't evolve with any of that. And so the theory is that, not my theory, really just the smartest immunologists in the world, that at the same time we're too clean, we're too toxic. So we take an immune system, remove its friends, introduce unknown actors all the time, and the immune system starts to get confused. Now, to make that more complicated, if you followed me thus far, social threats, you want me to go here? Mm-hmm. I thought you did. Mm-hmm. Social threats across evolutionary time, like being ostracized or made fun of or excluded, were extremely dangerous across evolutionary time for two reasons. Our immune system evolved to respond to threats in general by producing a big rush of inflammatory hormones and chemicals. Reason being, let's say it's the 1500s, you're walking down the road, you caught a rabbit for dinner, yay for you, you're headed home to your little village hut, and you see a wolf. You go into fight, flight, freeze. Everybody knows what that is. Your immune system starts to pump out all these neurochemicals, which in the short term are great. But one of the things it also does is pump out all these inflammatory cytokines. Because across evolutionary time, if you were threatened, there was a very good chance that you were going to have a wound. And if you had a wound across all of evolutionary time, it came in a threat circumstance, and you needed those cytokines to burst forward and protect you from any pathogens that were harmful in the environment and infection. Now, if I've set the stage properly, you know that the threat response is now really referred to as the threat immune response, or the stress immune response. We don't think of a stress response as being separate from an immune response anymore. We just don't. The stress immune response responds when we are threatened or when we're under chronic, unpredictable toxic stress. So, in steps, social threat. Over time, social threat is experienced by our body as a physical threat for a very good reason. The most socially threatening thing, the most immunologically threatening thing that can ever happen to you across evolutionary time is being ostracized. You are set outside the tribe. You are set outside of food. You are set outside of water. You are set outside of human protection. You are open season for warring tribes. You're open season for animals, predators. Your immune response better be really good if you're going to be ostracized, because you got to survive alone. Your immune system needs to pump it out, baby, to keep you alive alone. So we've introduced a lot of social threats, and immunologists can see that social threat from different things like social media and social threats in our very kind of toxic climate are causing the immune response to prick up as if there is a predator and not settle down. And over time, this leads to immunological changes in the body and in the brain.
Thank you. I found that part very
It's pretty fascinating. So. You can see why I'm going to write a whole new book about.
Yeah.
Yeah. It's crazy. Sometimes you're a reporter and your mind is just blown. Yeah.
So we're going to turn over to Q&A in a little bit. So I'm going to use the last question, a little bit selfishly, to ask you. There are a lot of autoimmune diseases, a lot of mental illnesses mentioned in this book. But one thing that doesn't come up is addiction and substance use, which is also, the way we talk about the growing anxiety and depression in our country. There are also, addiction epidemic.
Yes.
I'm wondering what, if anything, we know about the role microglia play in addiction.
So as a reporter, you can only go where you know, right? And we don't know. But because we know that microglia, when they are overstimulated, they over-prune synapses. Can see that in the lab. We also know that in individuals with depression, OCD, mood disorders, anxiety, addiction, that very specific connections in the brain, in what we now call the connectome of the brain, are impaired. They're not connecting, they're not firing and wiring together. So we can see on brain scans that this is true in specific patterns. And this research is just really accelerating at a very rapid pace. We know this is true in addiction as well in the threat reward centers of the brain. So we can hypothesize that microglia are involved, but that hasn't been shown in the way it's been shown in Alzheimer's, for instance. And so I won't go where I don't know. Right? I can say that I can just imagine we're going there, but we haven't gone there yet. This is all so new in the history of neuroscience, this new understanding that the brain is an immune organ and that microglia rule the brain and are the governors of how we feel is not even a millisecond in the history of science.
All right, well, thank you so much.
Thank you.
Now I'm sure people have questions, so we'll let you take over my job.
If you have a question, feel free to raise your hand. Yep.
There is a camp that rejects the materialist understanding of the brain. And it seems like, if I am appreciating your position correctly, that you have made a substantial case, an even more profound substantial case for the materialist brain. So where do you sit in the materialist versus non-materialist camps?
My son is getting his PhD in philosophy at Berkeley. You mind if I call him? Sounds like I was talking to him driving up here, and we were having a conversation a little bit like that. I think you're talking about this idea of consciousness and what creates consciousness, right? And so I would argue that I have added to both camps. Sorry. On the one hand, it is material. The scientists have added to our material understanding of the brain, and new tools have allowed us to do that. I mean, the past 7 to 8 years, our ability to use high-resolution tools to look in the brain and watch these cells in real time, it's just staggering. I've stood in labs and watched this. It cannot be denied, right? On the other hand, this idea that microglia are these very sensitive cells that are seeing what's coming before you even know and are creating this making and unmaking of the self by what's happening around us and how we are interpreting it, responding to it, and managing it, and the world that we're creating for ourselves kind of also gives us a new road into consciousness. So I'm kind of curious where that's going to go. I'm just curious. We can use the science sometimes, for two different arguments at the same time, hence the field of philosophy.
Yeah. A question over here. Yes.
So I would happily invite you into the both and world instead of the either or world.
Yes.
Where the truth is more likely to be balanced.
Yes.
I wonder if you could speak briefly to the epigenetic role of emotions. I haven't had a chance to read your book yet, but I noticed you related to that. And somebody who's not just mind-body medicine, which is finally getting a lot of attention, but mind-body-spirit, and you've referred several times to recognizing that we operate as a whole, not with separate parts. And that's true at every level. So if you would address some of your understanding of the epigenetic role of
I love
emotions,
epigenetics.
and also the cardio brain communications are going.
Well, starting with the latter question, we know a lot about, so the brain is an electrical organ, right? And so is the heart. I know that really well. I have a pacemaker. I've had it since I was a kid. So it helps my brain. It helps my heart. Sorry, seeing a good Freudian slip there. It helps my heart to keep working as an electrical organ. More and more, we understand that microglia are forming the electrical field of the brain, and they are forming what we call the direct field in the brain from which all brain waves emit. So if you think of it that way, of course, the brain and the heart are going to be connected, and we also know that if you get a really sudden bereaving shock that causes you to be in deep bereavement, it will cause changes in the heart, which look just like a heart attack, but we call it broken heart syndrome. So it's slightly different. So there are all kinds of things that we don't fully know about that connection, but we are getting there. As for epigenetics, I love epigenetics. I wrote a whole book about epigenetics called Childhood Disrupted, about epigenetics early in life, turning on genes and turning off genes. So any of you who read that book know that epigenetics are dear to my heart. And that is an awareness that the different things we're exposed to for instance, adversity in childhood, chronic unpredictable stress without reliable adults. That could be household dysfunction. It could be a parent with untreated depression. It could be a parent with a substance abuse. It could be living with community violence, poverty, racism. There are now 17 different categories of adverse childhood experiences. There might be slightly more. Barbara, you might also know a little bit, but and all of these exposures over time begin to change the genes that turn on and turn off the stress response. So genes are kind of like flowers. They're supposed to bloom and flower as we come of age. Think of epigenetics really simply. When genes change negatively through epigenetics, through being exposed to certain things in the environment, certain petals don't flower. They don't open, right? So the genes that should turn on the stress response, what we think of as the sympathetic nervous system, fight, flight, freeze, turn it off, go back into homeostasis, what we think of as the parasympathetic nervous system, or rest, digest, and relaxation. We can see in kids who've had maltreatment or adverse childhood experiences without intervention that the genes that turn that stress response on and turn it off get stuck in the on position in that high and we can see those changes to the genes that oversee the stress response on all 23 chromosomes. That's research out of Yale. So epigenetics really matter, but they matter throughout the lifespan, right? So the brain is, now we don't think of it so much as just neurons. We think of the brain in these neuronal microglial units. I know, it's like very techy, but these units, these neurons and microglia are dancing together through life, through our life. And if we turn on certain genes that express, which is another way of talking about epigenetics, if the stress response is on too high, it will express through microglia genes that are associated with depression, Alzheimer's, lack of chemical production of sufficient dopamine, serotonin. So at MIT, somebody said it perfectly to me, Li Wei Sai, who's head of Peak Hour. Microglia are like a light switch in the brain. They are responsible for turning on and off a lot of different genes we associate with disease, which when we say turn genes on and off, the most complex word for that is gene methylation. The middle word for that is epigenetics, right? And the easy word is on-off. So I hope that I got to your question.
Question in the fourth row.
I was wondering if you could comment about not just social media, but if you think about the 24-hour news cycle
Sure,
and
yeah.
the kind of news and
I was
climate
hinting at that.
we're currently living in, and especially if any research has been done about what it takes for I don't know how to say it, brain, body, mind, spirit, heart, the whole connected system to recover in terms of downtime or taking media breaks or whatever you need to do for self-care.
I'm a little concerned as a journalist to hear what this means about my lifestyle.
Yeah, right. You and me both, right? Yeah, right. We can't turn the news off. So I think I would say that the brain needs a rest from threat. And I think we're all smart enough to know what that means, right? Had somebody sat there and said, you need 20 hours off and 4 hours on, or, that work hasn't really been done. What we do know is that the more time people spend on social media, the more that's correlated with, we don't know if it's causal, to depression and anxiety. So we do see time-related associations, but as far as I know, as best I know, no one has done a study on how much time away. I would think right now we could all use like a month on an island, but it could just be me. Yeah.
I'm ready to join you on the island. No
Let's
worries.
go.
Hi, I'm hard to understand, so I'll talk slow.
We have all the time in the world. I do anyway.
I am a reflexologist, serious at it. About 6 years ago, I learned a protocol from an acupuncturist and Taoist from Vietnam. And we call it the colon-brain link. Mm-hmm. And I bore every client by telling them to heal, you need to change your diet, and you need to meditate.
Yeah.
So I haven't read your book yet. But my question is, do you offer solutions through alternative therapies in this book?
Yes.
Okay.
Yes.
And
I'm all in, yeah.
and do you have a preference? Do you talk about Qigong and Taoism?
It's a great question. So again, I've been doing this for just a little bit of time, and I have reported on meditation. I wrote a book about the science of meditation called The Last Best Cure. And so, yes. So if you're thinking about it, I'm probably thinking about it. So I devoted that entire book to the science of changing the brain and changing this production of stress chemicals through practices like Tai Chi, meditation, yoga, all of the things which bring down the threat response that we can just do right here, right now. We don't have to pay anybody, we don't have to go anywhere. And looking at that data, looking at that real research, and how it can help shift those epigenetic changes that are negative back again. It's pretty wild. It's the oldest available and longest known type of therapy in the world. Maybe it has been around for 2,000 years for a reason, right? Maybe. So as far as the colon, yes, I do. I think I cover about 15 therapies in the book. I don't do it like a self-help book, like, here's this therapy, do that. I follow people who are doing it. I talk to the researchers who are studying it because I'm very research-based. I don't ever want to put anything out there that we don't know just a little bit about. I want to see a couple of double-blind randomized clinical trials, and then I want to tell you about it, and I want to say, okay, there were these 2 clinical trials. They were double-blind, they're randomized, they're controlled, but they had 100 people in them. Right? Or I might say, there were 17,000 people in this, and then there was another one, 30,000 people. So, for instance, we know that microglia talk with microbes in our gut. They're chatting. They chat through the vagus nerve, right? So it's a big thing like 7 years ago when we discovered that the brain in the gut is about 80% immune cells. That was another whole... It's like the whole immune system is taking over the whole body. Oh, wait, maybe it was always there, So those immune cells in your gut are chatting via the vagus nerve, which comes down from the brainstem all the way through all your organs, including your heart. It moderates temperature, sweat, heart rate, and microglia are getting messages from microbes and immune cells in the gut, including about production of serotonin. So it's just wild research. It's a wild time in science. And we can see that when you introduce messages to the gut, that you aren't going to get very much food for a little while. This is fascinating research going on at Hopkins and University of Southern California. It tells the body that in order to be safe, you have to shrink down and get rid of some of your toxic cells. And in the brain, this causes some of the toxic microglia to shrink up and die away, and good microglia to get busier. So this is very early, very limited clinical trials. So I am in no way telling you guys run out there and try a fasting mimicking diet or what, the different diets. You don't eat for 14 hours and then you eat for like a 8-hour window. I just give you the science. I tell you what we know and we don't know. And I ask you to go to your doctor, because if we're talking about diet here, we have a real epidemic of terrible diets in this country, of girls dieting, of anorexia. So I'm not ever going to sit here and say fasting is a way to improve your brain. I'm going to say ask your doctor. Are there limitations for people with autoimmune disease? Can cause fainting and some other disorders. But I just think it's very cool that we're finding all these different ways to talk to our immune system other than or in addition to medications. I think that in the next 5 to 10 years, we're going to see some amazing stuff.
Donna, we have a question up on the balcony. If you go up and to your right, over here.
Hi.
Hi. You were kind of getting to the answer to my question, and it was with regards to number one, the diagnosis. You say go to your medical doctor or go to your doctor. Doesn't sound this is something like my primary care physician would know about.
Great question.
So what's the testing for this?
Great question.
And then secondly, because it seems to be so related to other autoimmune deficiencies, is it misdiagnosed quite often? I mean, this one cell in a million, is it easy to detect? It sounds like it's not. So when you go to your doctor, your psychiatrist, and you talk about these symptoms you're having, are many times our patients misdiagnosed?
So I wish we were even that far along, right? I wish we were even that far along where you would go to your doctor and you'd say, hey, I want to know if I have any microglia-related diseases. And you'd be like, what? We're not there. So let me tell you where we are and where we can hope to be. So we know lots of things, and you know this as a reporter. You see lots of things that give you information about the big gestalt picture. Here's what we know. That in patients with chronic inflammation, as measured by C-reactive protein, IL-6, and other inflammatory factors, that in those patients, we almost always see heightened activity of microglia in the brain. Okay? We also know that in patients with a range of neuropsychiatric diseases, from OCD to major depressive disorder to bipolar to Alzheimer's, we see higher levels of microglial activation in the brain. We're still figuring out exactly what that means in a way that maybe in 5 years could be correlated to, say, a white blood cell count. Does everybody know what your white blood cell count? It tells your doctor, like, what's going on with your immune system? Is it really pumping out a lot, which could be good if you have an infection? Or is it underactive? Or is it kind of just right? We also know from work going on at Shock Trauma in Maryland, a researcher there who specializes in concussion, he found that when microglia are overactive, they create factors that descend into the bloodstream. And he's been able to test them, and his hope is, if he can get the funding to do it, is to use those levels of microglial factorial activity to determine whether a concussion was mild, moderate, or severe, because we don't always know. And over time, if we can use some of these tests that are now in development, we can not only help judge, well, is there too much neural pruning going on there in this individual? Is there too much toxicity in the brain, what we call neuroinflammation? But we'll be able to do something else that's super important. We'll be able to tell if treatments are working, right? Because if you see that somebody's white blood cell count in the body is way too high, or cholesterol is way too high, and you tell them to do 5 things, one at a time, you're going to be able to see by retesting if they're working. So at Broad Institute, which is a consortium of research institutes at MIT and Harvard and Boston Children's, they are working to look at microglia as they shift from their angelic state in the brain, where they're good doctors, into being Pac-Man-like assassins and eating synapses and spitting out neurotoxins. They are tagging them, okay, angel, 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 thinking about being bad, kind of not sure what you're doing, starting to be a little toxic, rogue bad agent. And as those little, think of them like barcodes at the grocery store when you're checking out, you know, the barcode can tell the person who's checking you out like what you're buying, and it tells, you know, the expiration date. These little barcodes on microglia, which are read by looking at different aspects of them that I won't go into because it'd take me 3 chalkboards, but to look at that and know, oh, okay, these are shifting into a negative state will be very, very helpful with diagnostics, but again, with treatment. So right now, the brain is a black box. We put drugs in it, and we hope they're working, but different drugs, different pharmaceuticals and different antidepressants work for different people. We don't always know why, right? We don't know why. We think that antidepressants, when they work in about 33% of people, they work because they are allowing for neurogenesis. It takes 2 to 3 weeks for them to kick in. That is how long it takes for neurons to start making synaptic firing again. And that can only happen if microglia stop eating them. So it's really just the beginning of this time of exploration, and you definitely, I'm sorry, cannot go into your doctor and say, hey man, how my microglia doing? I mean, you could if you want her to pass out.
You touched upon this a little bit, but there's been an incredible amount of research recently about the gut microbiome and the connection between the brain and the microbiome. Has there been any real correlations recently in terms of how that affects the microglia and what we can do to look at the various microbiomes that exist?
Well, I mean, the best research that we have on that is coming out of these fasting mimicking diet experiments at USC and at Hopkins. And what they are finding is that they are able to influence. So think about it also if you're doing intermittent fasting and you're following one of these programs. When you are eating for those 8 hours, you're eating like all vegetables, you know, really healthy food. You're not like going and eating Big Macs for that period of time. Most of these different fasting mimicking diets or intermittent fasting that you would do with a doctor, they're including really healthy food. And so you could infer from that this cleaning out of the gut is sending good messages to microglia. We think we know that. We also know that in 2015, and I write a whole chapter about Yoni Kipnis in the book at UVA, when I set the stage for the contrast between what we thought we knew and what we know now, I should have added that we did not think that any lymphatic vessels, which are the vessels that ferry our immune cells through our body, our white blood cells, so that they can do the good work that they do. Like if you fall down and you skin your knee, your lymphatic vessels carry your white blood cells and your T cells to the site of injury so that there can be some good inflammation and also fight off any pathogens. So we did not think that lymphatic vessels carrying our immune cells came above the neck. And Yoni Kipnis in 2015 found that they rise all the way to the brain. So our immune cells really don't have to, our immune molecules don't have to go up through the blood-brain barrier. First of all, they're talking with immune cells in the brain we didn't know existed, microglia, through the gut, through the vagal system, through our body's white blood cells. They're cousins in the body. And those white blood cells and T cells are rushing right to the brain to shout messages at microglia. So it's an entirely new way of looking at how every organ in the body, including the gut and digestive tract, is connected to this organ.
Second row to the right.
Hello.
Hi.
So with all this burst of information coming out with medical marijuana and CBD and the THCs and the terpenes and things, so in the studies with the microglia now, are they doing studies with looking at CBD oils and THC and medical marijuana?
Plenty of neuroscientists are looking at CBD and marijuana. I do not know of anyone who's looking at microglia specifically, and I feel like I would know if someone was. And of course, we have to be careful because marijuana is also associated in the literature with schizophrenia. So in CBD oil, I know CBD and marijuana are different. But the neuroscientist that I do know who's the big researcher in this area, I know the rush and the desire for this to be something that's really helpful with anxiety and chronic pain. And I think that there's a lot there, but there are also some cautions for certain genetic subsets. And we have to take those really seriously too. I do not know if anyone is looking specifically at microglia. I feel like I would know, but something could have happened in the last month or so. So I can't 100% answer, but I do think the literature on medical marijuana is one thing. The literature on marijuana, which is not necessarily what kids are exposed to. They're not exposed to medical marijuana. They're exposed to marijuana. And the development of schizophrenia is of real concern. So it's a mixed picture. Like science is like that. It's really complicated. Yes. Yeah, and that I don't know. So somebody will get there. Like right now, we're still trying to catch up with the threat reward circuit and addiction and microglia. Like this is just, if you talk to the top 50 neuroscientists or immunologists in the world, they're all going to this cell. Every single one of them is changing the way that we look at, and it's causing the two fields of neuroscience and immunology to become one. The one field that we don't seem to be able to get into this conversation, anybody want to guess? Say it together. Psychiatry does not seem to want to be involved in this conversation, which is why I wrote that disruptive op-ed for the Boston Globe and a few other places since. Yeah.
We have time for just one last question in the fourth row.
So you kind of touched on how the SSRIs, that psych issues have been treated the same for the past 30 years. I work in women's health, so that really resonated with me. And I was thinking about how I was curious on your opinion on hormone replacement therapy and also like contraceptives and the way that we kind of use those, not necessarily the bioequivalent hormones, to shut down that system, and how it relates to depression. And that's been the same for the past 30 years as well, and where you think the study of microglia are going for like women's health in general and like the hormone aspect of it.
So I just want to be really honest. I'm starting to look at that more myself. Nobody knows And I'm really curious because as we are including women more and more in health studies, we're starting to get an idea of sex differences. And if I'm really going to blow your mind when I say this, it'll be like one of the last things I say, microglia appear to be sex differentiated in some ways because of the estrogen response. Okay, so I'm really curious about that. I was literally reading about it this afternoon because I'm really nerdy that way. And I'm trying to figure this out, and I have a call this week with someone to figure out a little bit more. So I really can't answer that, but I am curious with you because if the stress immune response is much higher in women, like even we know if you give vaccines to women versus men, women have a much more robust response to the vaccine. Again, it's protective of the potential fetus, right? So how we manage hormones for good or for ill is definitely going to affect that stress immune threat response. And how do we do that in good ways? It's really a question. I mean, we really just started asking these questions about estrogen a few years ago. So I can't answer, but I would like to be able to next time I see you.
Can we give Donna and Aneri a huge round of applause?